Let's discuss on-site oil analysis for industrial facilities. What is the benefit of on-site oil analysis? It provides immediate benefits and immediate answers to the condition of any lubricated equipment. It looks things at proper lubrication, early detection of wear, and contamination control. Why is that important? Well, all of these factors help a site manager and a maintenance manager to reduce risk. The earlier that you have an indication that something is going wrong, the greater that is your chance to alleviate or to solve the problem. This is very important for industrial facilities nowadays because anybody who's involved in some sort of discrete or process industrial production are all managing their systems based off of KPIs or knowledge performance indicators. And on-site oil analysis affects your production KPIs in a good way. There's a variety of different systems out there, and as a industrial facility, be aware of the major KPIs that are affecting your facility. It could be percentage uptime on reliability of equipment, the percent of reactive maintenance that's needed, the percentage maintenance cost over replacement of the asset value, overall equipment effectiveness, the amount of inventory turns or the amount of MRO or maintenance and reliability operational parts in stock, mean time between failures. All of these metrics are very important. There's different types of world class out there. Everybody's trying to aim for at least greater than 90%. And what's really important is to have some sort of on-site oil analysis program, but it does not live in a vacuum on its own. This on-site oil analysis solution is part or integral to an optimized on-site lubrication program that is endemic across the site and affects all components that are acid lubricated. Why do we care about that? Well, the challenges to improvement on a lubrication site. The reason oil analysis wasn't performed for many years is because, first of all, there's a huge variety of equipment, as we'll see shortly. Different types of rotating and reciprocating equipment, different duty cycles, different components, different lubricants, very, very large amount of diversity throughout the site. There's a lack of understanding of what oil analysis traditionally did. Usually it was a marketing tool from an oil company, or there was a reliance on outside lab vendors or testing companies to do the work. Poor lubrication practices. Usually in the past, lubrication practices was assigned to the lowest skilled personnel in the site as opposed to the qualified skill craft. There was a lack of expertise to diagnose the results. So even if you got a result back from a testing operation, you didn't actually know how to diagnose that, and it wasn't always site specific. So a lot of the information tended to be very generic terms and generic diagnostics. And so because of that, there was a tendency to stuff it in a filing cabinet. And so as a result of that, there was a lack of action when there was issues, and not much action was taken. So as a result of that, the oil analysis program became more of a CYA operation. What we're looking for in typical industrial sites, as I said earlier, is there's such a diversity of equipment. We can have motors and drives that are oil lubricated, hydraulic systems, you can have air compressor systems, chillers, robotic arms on discrete manufacturing systems, conveyor belts for process line control, backup gen sets, free fire water pumps, as well as process fluid pumps. The powerhouse can be all on its own. It can have its own gen set, or it can have the power being supplied by a dedicated site. Machine tools will provide a lot of different fluids like spindles and valves, lubricating fluids. Same thing with rollers, variety of different systems, and you can have a variety of valves and seals. So at any one particular site, you can have anywhere from 5 to 20,000 pieces of equipment for lubrication on very large integrated complexes that runs into the hundreds of thousands. So having a dedicated program has a major effect on what you're trying to do. So let's discuss the type of tests that are normally used for a variety of industrial equipment to help understand the variety of systems that are out there and the different needs. So typical types of equipment, things like pumps or motor bearings, these can be circulating or they can be self-contained. If they're oil lubricated, you're going to have a series of tests that you need to do, which are, all of these tests are designed, again, as we said earlier, to look for contamination, to look at the chemistry of the fluid to see if it's okay, and to catch any advance warning of abnormal wear. So for pump and motor bearings, you always want to be looking at water content, viscosity. You want to look at oxidation to indicate the chemistry, if the oil is still fit for use. You want to look at ferrous density to see if there's any large ferrous wear getting into the system. Elemental spectroscopy, if you can do it, will give you an idea on the wear, the very fine wear, contaminants and additives in the oil. Particle count, only if it's a filtered system. If it's a self-contained system, it's not worth it. Likewise, with ferrous particle count, and those are the key tests that you want to be watching for. For gears and drives, much of the same tests, with a big focus again on the particle count and the wear side, because that's very important, because that's advance notice. Those type of systems are subject to different load and duty cycles depending on the process flow in the industrial facility. So as a result of that, the wear is not always consistent, the wear rates may change, and so you have to keep a tight control on those limits. When those systems go out of spec is when you start to have problems. Chillers, compressor systems, as we know, compressed air and chilled air are very important for process nowadays. Many of these tests apply. Viscosity is important, but provided you make sure you take the refrigerant out of the oil because it has to be separated out, or be aware of that. Those are the key tests that need to be done. You may want to run a total base number sometimes if it's a ammonia refrigerant in the chiller. Robots are a very popular and expanding capability for fluid analysis, but particularly grease analysis. So in those situations with grease on these systems, you want to be looking at the water content, oxidation of the grease. You definitely want to look at ferrous density. That can be up as high as 15% iron, especially because the material is not moving away. The grease keeps it in situ. And elemental spectroscopy to tell you if the grease is the right grease in terms of the additive package and if there's any corrosion effects going on. Hydraulic systems, very common. Again, all of these systems are important, but in particular focus on the cleanliness, because you're worried about filtration of the hydraulic fluid. It transmits power, so filtration is a major issue, so particle count takes a major role, because the clearances on hydraulic servo valves are so tight nowadays that particles that are in the micron size are going to have an effect. Backup gensets and engine-driven systems, you certainly want to look at water content. You want to look at viscosity at 40 and 100 if you have it, or a VI index to calculate out that viscosity at 100, because multi-grade oils tend to measure it on 100. 10 only if you've got a natural gas engine system. We do recommend elemental spectroscopy because of the fine wear, and also we do recommend nitration soot fuel dilution as well as TBN on any engine set, especially on a recip system. Spindles, machine tools, things like that, you want to be looking at your most common types of tests: water, your viscosity, your oxidation readings, your ferrous density, because that's indicative of wear that's present in the system. In all situations, the reason why we do this is we are trying to reduce risk. If we reduce risk, we improve our KPIs, but we also lower our insurance costs, and we improve safety, and we improve the environment for the worker and for the process. And that's very important nowadays when we talk about asset integrity and asset integrity management, because we're looking at a more holistic approach, which includes not just the reliability, but the safety factors included as well. In all of these situations, we would urge you to investigate the Mini-Lab series of product solutions. There's a variety of different systems there, ranging from the 23 up to the 153. All of them have a mix and match, and it's flexible. It can the performance is necessary for these type of industrial environments, and the flexibility is there for you to either go based on budget or based on specific product need distributed throughout the site.